Have you ever wondered how a food delivery app instantly knows the exact inventory of a restaurant's kitchen the second you search for a pizza? To understand how this works, think of a physical restaurant. You are the customer sitting at the table, representing the app user. The kitchen, where all the ingredients are stored and prepared, represents the database. Here, the waiter steps in. They carry your specific order from the table to the kitchen and return with the food. In software, the Application Programming Interface, or API, handles that exact same task. This separation is a deliberate architectural choice. You don't walk into the kitchen to cook your own meal. Keeping the API in the middle ensures that users never have direct, unsecured access to a company's database. Let's translate that physical restaurant into a digital architecture using an app like Swiggy. The interface you see on your phone, the menus, buttons, and images, is the front end, also known as the client. On the other side is the backend, consisting of the server and the database. This is where the actual business logic lives, and where all the restaurant data is securely stored. This flowchart illustrates how they connect. The API bridge translates front-end actions, built with HTML and CSS, into backend commands for Java or Python. When you search, the client sends a request over the bridge, and the API carries database results back to your screen. Mapping this invisible data flow is the first step. Before you can verify if an application is working, you have to map exactly how its components communicate. Traditionally, verifying an app works meant relying on UI testing. Using tools like Selenium, testers open browsers and programmatically simulate a user clicking buttons and filling out forms. At an enterprise scale, this creates significant bottlenecks. Waiting for visual elements to render makes UI testing slow, and simple changes to the position of a login button can cause the automated test to fail entirely. This racetrack shows the modern alternative, API testing. Using Postman, you bypass the visual interface, sending requests straight to the backend. The efficiency is immediate. The API test instantly returns a result, while the UI test struggles to load the browser window. Companies prioritize API testing because it allows for faster execution. Catching bugs at the backend layer allows developers to detect problems before the user interface is even finished. Let's map the waiter analogy to technical terms. The order is the request, targeting a specific kitchen endpoint. The data format is JSON, and the returned food is the response. The status code shows the result: 200 for success, 404 for item not found. Let's practice. Mentally map client, server, request, and response to this weather app diagram before the timer ends. The phone is your client, the cloud is the server, the right arrow is the request, and the returned temperature data is the response. Internalizing this vocabulary transitions a software tester from someone who merely clicks buttons on a screen into someone who can precisely engineer and validate systems. Let's apply this vocabulary to one final real-world scenario you likely use every day, clicking Login with Google. Instead of manually typing a password, your client app hits a specific Google endpoint with an authentication request. Google's backend validates your credentials and sends back a JSON response attached to a 200 status code, granting you access. This comparison matrix summarizes exactly why we test at this backend layer. Take a screenshot for your notes. It breaks down the differences in speed and stability between UI and API testing. Mastering this architecture is what makes industrial-scale automation possible. Now that you understand the role of the middleman, join me in the next video where we will open Postman and build your first HTTP request.